Hello and welcome to this mini lesson on Eulerian graphs, which is a topic that we meet in decision maths. The idea of graph theory was originally introduced by Leonhard Euler, who was a Swiss mathematician working in the 18th century. And what Euler thought of as a graph was a bit different from what you're used to with x-axes and y-axes. A graph in this sense is a network of points and lines joining the points together. Euler called the points nodes, and the lines which connected up the nodes were called arcs. And he introduced this notation to consider a problem which you can find out more about on the accompanying video, which was whether you could trace all the way around the network with your pen or pencil without going over the same line twice and without taking your pen off the paper. So if we look at this one, if I start here and draw around the graph, so I go along that line and down here, around the bottom and along that line, you'll see I'm a bit stuck because once I get into this point here, I can't get out of it. You may be able to think of a way, based on the same graph, that you could go around and you could draw that without repeating yourself and without needing to take your pen off the paper. Okay, and the key really is if we start here and we go around the edge like this, keep going all the way around the edge, and then finally we go across the middle last, so we end up at this node over here, and we've gone all the way around the graph. We've used each arc once. We haven't ended up where we started from. So this is what Euler called a semi-Eulerian graph. An Eulerian graph would be one where we could draw a trail that went all the way around and finished where it started from. So if I draw you another graph, you might want to pause the video when you've seen the graph and see if you can go all the way around the edge of that without taking your pen off the paper and without repeating yourself. So pause it and have a go. And what you probably found was you could start pretty much anywhere on this graph. I'm going to start over here, but it's not the only place you can start. You might think, well, I'll go around the outside first of all, then I'll go around the middle, and I'll finish up back on the outside again. Or you might think, well, actually I'll start at one of these points like this and do all of the inside, then all of the outside. There's a number of ways of doing it differently, and you should end up with an Eulerian graph here. Right, so we're going to try a few of these, and then we're going to come up with a pattern which lets you decide whether it's Eulerian or semi-Eulerian. So this one first, if you have a go at, copy it out on a piece of paper, see whether you think it's Eulerian or semi-Eulerian. I'll pause the video and then we can have a look in a minute. Okay, so I'll pause it now. And I don't know how you got on with that one, but I got a bit stuck. Even if I start here, go around this little triangle first, so we've got a tricky bit out of the way, and then go around here, and then do this triangle. If I end up down here, I get stuck here and I can't get back out for that bit. Or if I do this bit, then I can't do that bit. This graph, unfortunately, is neither Eulerian or semi-Eulerian. See if you can think of what it is about each of them that's making them Eulerian, semi-Eulerian, or neither. Have a go at this one next, okay? So pause the video and try it. Now this one, you should discover you can get an Eulerian cycle around it. So I'm going to go around the edge like this, up to this point, down to the middle, down to this corner again, out of here. I don't want to go straight up to the place where I finished. I want to go around this triangle first of all, like that, then finish up back here. This ends up as an Eulerian cycle. So you can probably guess what the third one's going to be. The third one's going to be semi-Eulerian. Think carefully with this one. You're going to start at one point and finish at another point. So pause it and have a go. And what you should find is that you have to either start here and finish here, or vice versa. I'm going to start here. I'm going to go round this end like this. Then I'm going to go to the middle and out again. Then I'm going to get the finish, but I'm going to go past the finish, around this triangle, and back into the finish again. And that gets me a semi-Eulerian graph. Now, what's the trick here then? How do we know which one it's going to be? It all depends on the order of the nodes. So if you have a node like this that's got 4 arcs coming out of it, that node's got order 4. Whereas a node like this would have order 3. So let's label up. This node's got order 2, that one's 3, 3, 2, 3, 3. On the Eulerian graph, we got 2, this one's got order 4, 1, 2, 3, 4 again, 2, 4, the one in the middle's 4, and that one's 4. On the semi-Eulerian, these two at this end, the start and finish, have got order 3. Those ones have got order 4, and this one's got order 2. So what's the pattern? You should spot, with the Eulerian graph, everything's got even order. That means every point, the trail goes into the point as many times as it comes out of the point. So this point here, it's got order 2, it's visited into the point and out of the point. This one with order 4, the trail went into it and out of it. When it came back again, it went into it and out of it. So, if all the nodes are even, we get an Eulerian graph. If exactly 2 of the nodes are odd, we can get a trail that starts at one of the odd nodes and finishes at the other. Right, so I'll give you a sheet of questions to have a look at after you've done this video, and I encourage you to come back later in the week to check your answers. Whilst you're on the website, I'd encourage you to try some of the other maths mini lessons. So go on the maths subject website and click on some links, see what else you can find out. Thank you.